The forest is awfully silent. That means only one thing. There is danger. The fern leaves shiver. Dust hangs in the hot air. Somewhere beyond the trees, a large body moves through the shadows. This is Tyrannosaurus rex, the animal that every museum made us imagine as the king of the dinosaurs. But now you have to look lower because between the trunks, something is moving faster. It's not quite as massive or crushing, instead it is leaner and sharper. This is Nanotyrannus, the dinosaur that changed paleontology forever.
Talking about proof of a new tyrannosaur species,
which some researchers have proposed represent a species other than the tyrant king, named Nanotyrannus lancensis.
And what we found was that this controversial species called Nanotyrannus was actually a valid, legitimate species of dinosaur.
For decades, many scientists looked at fossils like this and interpreted them as just being a teenage Tyrannosaurus rex, essentially a tyrant that had not finished becoming a tyrant yet. But what if this was wrong? What if some of the teenage T-Rex skeletons were not teenagers at all? Now in this case, if we get a separate species, not just a growth stage, what would the teenage T-Rex skeletons actually look like? That is the double-sided question. What if the most famous predator in history had been sharing its world with another tyrant? A smaller, faster dinosaur, hiding in plain sight. This is the mystery of Nanotyrannus, and it begins in 1942, when a small tyrannosaur skull entered the story. It was not the skull of a giant predator. In fact, it was narrow and lightly built. It was different enough to be strange, but familiar enough to be controversial. Because it was discovered by a team from the Cleveland Museum of Natural History, it was dubbed the Cleveland Skull. And for decades, it sat at the center of a question that paleontology could not fathom. Was this the face of a young T-Rex? Or was it the face of something else? Something like a new species? That question matters because fossils give us evidence. For example, we have the remains of a skull, but none of the muscles are preserved. Or maybe we have the remains of the teeth, but we have no evidence of the prey. Or we may have bones, but no evidence of behavior. So it's the job of a paleontologist to interpret all that evidence and draw conclusions about the anatomy, biology, and biomechanics of prehistoric life. This is where the problem becomes more challenging than simply naming a dinosaur. Imagine finding two human skeletons with little to no clues about their provenance. One from a child, another from an adult. Their proportions would be different, the skulls would be different, and some bones would not even look like they finished developing. Without knowing the growth sequence, we could easily mistake age for identity. Paleontologists face the reverse problem here. They don't know the complete sequence in advance, meaning they have to reconstruct the sequence from the fossils themselves. So the question is not just whether the bones look different, it is also whether they're actually different in the way a young animal's growth stage is supposed to be different, versus just being a completely different species. For years, one argument was clear: the idea that Nanotyrannus was not real, and that these smaller skeletons may have just been T-Rex before the growth spurt, because it is very well known and documented that young animals can look quite different from adults. A juvenile predator may have a longer face, a lighter skull, and a more delicate body. And if you only have fossils, the line between different species and different age becomes blurry. Again, there's a lot of missing context that we have to infer as paleontologists. But then, to our benefit, more clues arrived, and the first thing they challenged was the old T-Rex body plan. A young Tyrannosaurus rex should grow in shape and proportion toward the mature T-Rex. Its bones should demonstrate a progression into that future. A juvenile is an animal on its way toward a particular adult anatomy, and we have clear visual and fossil details that can help us determine this. Its proportions may be unusual, but they should still belong to a recognizable growth trajectory. So if Nanotyrannus was only a juvenile T-Rex, we should see a clear progression. The bones should be predictably unfinished. And that is exactly where the juvenile explanation began to struggle, because Nanotyrannus had a different anatomy. Researchers identified dozens of differences across the skull. Almost every part of the skull seemed to indicate that this animal had a unique anatomy, and there is no clear intermediate form known to bridge that gap. That's where the mystery deepened. A teenage T-Rex should feel like a giant that is gradually developing. but this animal looked like a more complete dinosaur. You could say it looked like a different predator, a different solution to evolutionary pressures. And then came Jane, one of the most famous small tyrannosaur skeletons ever found. For years, Jane was often discussed as a possible juvenile Tyrannosaurus rex, a preview of the king before growing to a large size. This means that Jane was considered among the most valuable fossils we had unearthed about tyrannosaurs and theropods in general, but newer analysis placed Jane somewhere far more unexpected, not as a T-Rex or even just as the original Nanotyrannus. Instead, Jane was named as a second species, Nanotyrannus lethius. That turned the debate from one strange skull into something much larger in scale, because if Jane was not a young T-Rex, then we had definitely missed something important. The world during the time of Nanotyrannus and T-Rex was not just ruled by one tyrant in different growth stages. There was probably clear niche specialization, a set of hunters dividing the ecosystem based on unique predatory niches. This may be compared in a small degree to ecosystems such as the Morrison Formation, with Allosaurus, Torvosaurus, and Ceratosaurus as the top predators, or the Kemkem group of Africa, with Spinosaurus, Carcharodontosaurus, and Deltrodromeus, or an Abelisaurid, as the ones that partitioned into niches. Two predators can live in the same ecosystem while playing different roles. T-Rex and Nanotyrannus could both be tyrannosaurs while being built around different solutions. One is more heavy and destructive, the other is lighter and more precise. Niche partitioning means that the differences between them may have reduced direct competition by allowing each predator to specialize. The difference was also in the strategy. If we look at the arms, in T-Rex the arms are quite short, almost absurd next to the scale of the body. But Nanotyrannus had longer grasping forelimbs, which challenges the image. It was not simply a miniature Tyrannosaurus rex waiting to become huge. It may have been built around a different way of catching, holding, or controlling prey. Then if we look at the teeth, some of the premaxillary teeth, which are the small teeth at the very front of the upper jaw, were unserrated and chisel-shaped in Nanotyrannus. To a paleontologist, this is a clue. Teeth tell us what the mouth was doing, and these details suggest an animal that may have interacted with prey differently from the giant bone crusher that lived alongside it. But the biggest problem still remained: age. Because if Nanotyrannus was truly its own animal, scientists had to prove that at least some of these small tyrannosaurs were not simply young, and that meant cutting into bone. Inside bone, under the microscope, growth can leave rings, or lines of arrested growth. I like to call this a hidden timeline recorded in tissue. The outside of a fossil tells you what the animal looked like. The inside can tell you whether it was still becoming something else. A small skeleton could belong to a young giant, but a small skeleton with mature tissue tells a different story. It means the animal may not have been caught halfway through its transformation. The smaller body was not necessarily a temporary stage. It may have been the final growth stage. For Nanotyrannus, one of the most important places to look was the throat, including the hyoid bones. These are fragile elements connected to the tongue and throat, specifically ceratobranchial. These are bones most of you have probably never heard of, but are the key evidence here. They're rod-like cartilage located in the throat that formed the structure of the throat skeleton. They mattered because these throat bones could preserve growth records. In the holotype material of Nanotyrannus lancensis, the growth record suggested an animal nearing or already at skeletal maturity. This was not a young giant racing toward adulthood. It was a nearly grown or fully grown individual with a small body. And that small body was just one of the primary characteristics of this dinosaur. Then, the Dueling Dinosaurs pushed the story even further. This fossil is almost too cinematic to be real. It's a tyrannosaur and a horned dinosaur preserved together, locked in a scene that's basically worthy of a dinosaur documentary. The tyrannosaur inside that fossil is evidence. Histological analysis suggested this individual had reached skeletal maturity at around 20 years old, and it was still small compared with T-Rex. And that matters because growth rings indicate that if the animal was mature, then a small size was the final form. This means that adult Nanotyrannus may have reached roughly 3,300 pounds or 1,500 kilograms or less. That is large by human standards. It's another fierce predator with teeth, claws, and a skull built to kill. But next to Tyrannosaurus rex, it was a different category of predator. It may have been more like a pursuit predator. With this discovery, the image of the final days of the Cretaceous is changing. Instead of one giant tyrant dominating every role, imagine a much more complex world. A huge T-Rex moving through open ground, using mass and bite force as a strategy of destruction. And somewhere near the edges, a leaner Tyrannosaur moving through cover, which was faster on the turn and more precise in the strike. It shared the same landscape as Tyrannosaurus Rex. That is the insight. The king probably didn't rule alone. It lived alongside Nanotyrannus. And the correction goes even deeper. If the small Tyrannosaur skeletons are removed from T-Rex growth datasets, then the growth story of T-Rex itself has to be redefined. What would a juvenile T-Rex look like? T-Rex may have had a longer, more protracted development, with its full growth stretching toward an asymptote around 35 to 40 years of age. That makes the world of Tyrannosaurus Rex more vivid. For a long time, Nanotyrannus lived as a doubt. It was a name some accepted, while others rejected. It was a ghost in the museum drawers. That's why, for the sake of the argument, if Nanotyrannus was not real, then an entire predator would have been erased, because its bones, anatomy, and skull were present, but every specimen would have been absorbed into the life story of another animal, Tyrannosaurus Rex. Science had found a dinosaur, but had only recently recognized it as a separate species. But gradually, the phantom became harder to ignore. We had evidence, including the Cleveland skull, we had Jane, we had the Dueling Dinosaurs, the features of the skull, the arms, the teeth, and the throat bones. Each clue clarified the reality of the lost world where T-Rex and Nanotyrannus dwelled. We thought we knew what the final days of the Cretaceous were like. We pictured one lone king towering over the last days of the dinosaurs. There's always a new discovery waiting to be revealed for those curious enough to look closer and question what we perceive as a given. And sometimes we learn that we were wrong. Sometimes the question spawns a new species, such as Nanotyrannus, the tiny tyrant that was not tiny, the teenage T-Rex that may have never been a T-Rex at all. Thanks for watching, and I'll catch you in the next one, only on Enchiridion.